what I want to start with is this here. We're starting chapter 6. Exponential growth, exponential decay, and logarithmic functions, which are kind of their inverse. Exponential growth functions is any function like this here. And all we define an exponential growth function is a function whose numbers increase or decrease up and down faster as the numbers increase. I've already mentioned one of these, I believe, in the last chapter, because 2 to the x is an exponential growth function. Instead of 2 to the x. So I'm going to use this table here. You don't have to write this down. But when 2 to the x, when the x value is 0, the y value is 1. So 2 to the first, or 2 to the 0 is 1. Next one, 2 to the first is 2. Well, now it's going from 1 to 2, from 2 to 4, to 4 to 8, 8 to 16, 32, 64. Well, the amount it's increasing is getting bigger, faster, and faster. That's why it's exponential, because of how fast it's increasing. Now, that's just 2. Let's say 7 to the x. 1, 7, 49. We already got, it didn't even take 8, going 8 spots before it got too big for the cell, too big for that spot. Those numbers increase exponentially. Exponential growth, exponential decay. This is one of the few things that does show up everywhere, or shows up a lot more. Cockroach population is exponential increase because they increase at a fast rate. Tornadoes, earthquakes have this exponential growth. That's why if you ever wonder where they talk about the Richter scale, or even a tornado going from a 2 to a 3, the amount of damage they cause is so much more. Exponential growth, because that's how they rate those. And the biggest thing is with exponential growth and exponential decay is one main thing. It's right here. B, the base. So 2 to the x is exponential growth because 2 is bigger than what? 1. Exponential growth. Exponential decay. The base is between 0 and 1 is decay. I'm going to go back to the graph. So this one here in blue is 7 to the x. 1 over 7. Is this will. So again, the base is now less than 1, yes? Let's see what it does. From left to right, it's now going down. So if the base, and we call the base, this here, the number that we have to that x power, if that base is greater than 1, it's an exponential growth. If it's between 0 and 1, it's decay. Now we have these 4 here. It might look, I believe I rewrote the note sheets out, so there's more than that on each page. No, they're the same amount. I need to redo these. They're really small. We're doing 2 things. One, we're stating if it's growth or decay, and then we're evaluating, okay? If I look at A, y equals 2 to the x, is that exponential growth or decay? Growth. It is convenient. We also stated that a minute ago. Growth. We're not going to graph. Not because graphing's not important. One, the graphing calculator does it, and I'm not going to make you try to retrace that graph. And 2, the graphing calculator will do it. You know, and as much as the teachers that I had will say you'll never have a calculator be able to graph on you all the time, your phone will graph, do anything. You have it now. Okay, we good with the first part. And evaluate for x equals 2. Well, so it says y is equal to 2 to the x. Well, what's our value of x? 2 to the second, which is 4. 2 squared is 4. Because we're just saying we're multiplying 2 by itself. twice, so 2 times 2, 4. Or, there we go. We can do 2 to the second, which is 4. Yep. Now if we look at the next one, yes. Because our base in this case is 1/2. It's between 0 and, so this is decay. So we have 1/2 1/2 squared. So we're saying we're multiplying it by itself, yes? A half times a half is a fourth. Y equals 1.3 to the x. Growth. Even though it's a decimal, it's still greater than 1.3 squared. $1.69. How about 1/3? It is decay, because 1/3 is between 0 and 1. Now 1/3 squared, I need the parenthesis again. If we type it in, it'd be 1/9, because 1/3 times 1/3. Well, the 1 times 1 is 1, 3 times 3 is 9. And the calculator can do that for us too. Questions on this here? So this here, it's not asking us to evaluate, but I think we feel comfortable with that. It's just replacing x with whatever number it gives us. So if it's 2, we do 2. If it's 3.4, we do 3.4. Doesn't have to be a whole number. But if we look at the first one, 4 is growth. Because 4, our base is greater than 1. 2/3 would be decay, because that is between 0 and 1. 0.25, decay, because 0.25 is between. So f of x is just another way to write what? Y. Yeah, it's just function notation. So it's just another way to write y. And 1.5 to the x is growth, because 1.5 is greater than 1. If it's between 0 and 1, it's decay. If it's greater than 1, it's growth. Questions on this here? Now we have one other term. It's called the natural base e. It's an irrational number like pi. Now with e, so let's look at this here, natural base e. So e is approximately 2.71828182846. And that's just an approximation. Just like pi, we can't get to its actual value. And not to belabor the point too much, because really what they're doing to get that is they set x equal to 1, and then they did the same thing as x is 2. Natural base is defined as following as x approaches infinity. So they're just keep doing this here. I don't think it's plusing, but they're just doing this where x is continuously getting bigger and bigger to get that. So it is irrational. The way we get it's not too important. Okay. So e, like pi, like I, for the most part, we can treat it like a variable. Okay? We can treat it like a variable. So if I said e to the 3rd times e to the 6th, first guess, what do y'all think? It would be e. Yeah. Yeah. We can treat it for the most part like a variable, because it'd be the same as if we said x to the 3rd times x to the 6th. Well, that would be x to the 9th. So for our second one, 16 divided by 4 is 4 over 1, yes? So e to the fifth over e to the fourth is, I believe, what we have, yes? It would be 1, because when we divide like bases, we subtract the exponents. So 5 minus 4 is 1, yes? Is it bigger on top or bottom? So indeed, it would be 4e. 3e to the negative 4x squared. So we're squaring both terms. Now, since it's one term, we can apply that power to both. If we had, say, plus in the middle, then we would actually need to distribute property, multiply by itself. One term. So we're saying 3 squared e to the negative 4x times 2. Our powers of powers multiply. Because really we have 3 to the first. 1 times 2 is 2, so we just have 3 squared. Now 3 squared is 9. We have e, negative 4x times 2. Negative 8x. Now we can't leave it here mainly just because that exponent's negative. We don't like negative exponents. To make that exponent positive, we move it from the numerator to the denominator. So the reason we take the e with it is that negative 8x is attached to e. And anytime an exponent's negative, we can move it from the top of the fraction to the bottom or bottom to the top. And it changes its exponent sign from positive to negative or negative to positive. So it just flips the sign. Questions on A, B, C? Get ready for 1, 2, 3. Simple as do, re, mi. So number 1, e to the 7th times e to the 4th. E to the 11th, because when we multiply like bases, we add the exponents. (24/8) is 3. So e to the 8th over e to the 5th. So we didn't do this on the last one, but whenever we subtract or divide like bases, we subtract, yes? 8 minus 5 is 3, yes? If it's bigger on top, it stays on. If it's bigger on bottom, it stays on. So it'd be e to the 3rd. Now, if it had been the other way and it was bigger on bottom, we could have left it as e to the negative 3 on top, and then it would move to the bottom to correct that. 10e to the negative 3x cubed. So we have 10 cubed times e to the negative 3x times 3. Okay, since we have a term, one term, nothing's being added or subtracted inside there, we can just apply that 3 to both. If it had been 10 plus e, we have to do 10 plus e times 10 plus e and multiply it by itself. 10 cubed. It's 1,000. Because 10 squared, 10 times 10 is 100. Because really that power, we're just adding zeros. Negative 3x times 3 is, I think you did cubed. Because powers of powers multiply. So we're saying that we have e to the 3x multiplied by itself 3 times. So we add those 3's together. 3, 6, 9. Now because it's negative, we have to just move it to the bottom. Move it downstairs. What do you think of this so far? We're good? E, if E is the base, the exponent is what we look at for growth and decay. With base E, if the exponent's positive, it's growth. If the base is E and the exponent is negative, it's decay. That's it. Positive is growth, negative is decay. So if we look at this here, 3e to the x is growth. because the exponent is positive, yes? But what did we say e was? E is an actual number, yes? It's 2 point going on, yes? So here, the base for this here is our 2 point whatever. Well, that base is greater than 1, yes? So it is growth. So this is growth. The next one would be decay, because the exponent is negative, yes? Now, I'm going to do a little monkeying with this to kind of show you why. Because e, I'm going to move the x outside. But here, e to the negative 0.5, because the exponent is negative, we're moving it from the numerator to the denominator. So really what we have here is 1 over e to the 0.5, yes? Okay. Which doesn't mean a lot to us. 1 over e to the 0.5 is 0.6 going on, yes? According to what we had it originally, if it's between 0 and 1, it is decay. Because of that negative exponent, it moves that e from the top to the, making it between 0 and 1. Because if it's positive, like the first one, we have we have a number between, or not between, greater than 1. So it's growth. But we don't need all that. We just need to look at the next one. Y equals 1/2 e to the x. E's exponent, is it positive or negative? Positive, yes? So that would be what? Yep. Number 5. 4e to the negative x. Since the x is negative, this is decay. The next one would be growth, because if we look at the exponent, it's positive. So this is growth. That's it. This is by far the biggest, well, biggest in number of problems worksheet that we have. But 1 through 4, evaluate each expression for x equals -2 and x equals 3. So the first 4, you're plugging in -2 and 3 into it and getting both of those numbers. 5 through 14. You're welcome. 5 through 14. Determine if each function is exponential growth or exponential decay. So 5 through 14, you're just saying growth or decay. Thank you. 15 through 18. That's our properties of e, multiplying them together as we did there for a second. And simplifying. Yep. I'll do, what is it, number 18 with y'all? I prefer you write the whole thing, but because I don't think it'll take you too long to write growth decay. This one here is on the back, number 18. Now we can take each part, and the way that we do these here is the cubed root of 8 is 2. I think we've seen that way too many times by now, yes? For our sum and difference of perfect cubes. Now when we do this with exponents, with e, that 3 is being applied to the exponent. Powers of powers, multiplied, yes? So if you're going to take a guess, what do you think we do with radicals? Because subtract is a good root, but divide. So we divide 12x by 3, which is And that's it. Because we didn't specifically go over that one in class, but that's it. And then the last set, 1 through 4, you don't need to write growth or decay, so you're just going to do, for the first one, so 2 to the negative 2. And you can plug that in a calculator, let it do it for you. And x equals 3, so you're doing both. So 1 through 4 should have 2 solutions. No, we can do either one. Not 1 through 4. Because if it asks for it, yes. If it doesn't, no reason to give it. Because 5 through 14, 19 through 24 are the only ones that are really asking for that. So it would be 8 times 3 to the negative 2 first. So for 1 through 4, you're finding it for x equals negative 2 and x equals 3. So you'll do it twice. Preferably fractions, if it doesn't give it to you in fractions and there's no way to get it there. Yeah, so math, enter. Alternate fractional for the graphing calculator. So go one more down. So hit math, enter. Yeah. Yeah, 1/9. So the parentheses is just multiplication. Because I did have a dot there, but I think it was confusing to some. So I put parentheses. But same thing.